Hi, I'm Akmal Sayed, field engineer here at Wallaroo. In today's demo, we'll see how Wallaroo makes it seamless to implement and deploy a RAG workflow leveraging MongoDB's on-prem server hosted on an on-prem IBM Power10 node. By leveraging Wallaroo's most flexible framework, the custom framework, we'll start off by seeing how it allows us to implement our RAG workflow. We'll then see, with a few extra lines of code, how Wallaroo allows us to take that RAG workflow and upload it to Wallaroo, optimizing it for IBM's Power10 architecture. After that, we'll then publish it, making it available for us to use at an on-prem Power10 node. We'll start off in our notebook, which is our Python development environment for today. We'll begin with our setup by importing our libraries. Something I'd like to highlight is the line where we import Wallaroo. This is our pip installable Wallaroo library. This SDK is our interface interacting with Wallaroo using Python. Once imported, we'll finish setting up by connecting to our Wallaroo client and Wallaroo workspace. Now that the setup's complete, we can move on to uploading and publishing our model. In our first cell, with the help of PyArrow, we declare our input and output schemas. The input schema represents the inputs that our model expects to receive, and the output schema represents the data we anticipate to receive back from our model. In our instance, we've set it so that our model takes in the query and the customer ID, and in return, we get back the toRespond field, which is our RAG workflow's generated text. Once we have those schemas defined, we can move on to uploading our model. To do that, we'll use the upload model function. To it, we'll pass the model's name, its file path, the Wallaroo framework, which is custom in our instance, the schemas we defined earlier, and the architecture. Because we'd like our model to be configured to run on IBM's Power10 architecture, we can pass the value Power10 to the arc parameter. Something else you may have noticed is that for our file path, we refer to a zip file. The zip file is how we represent our model with Wallaroo's custom framework. Unpacking this zip file, we'll find that it consists of a main.py, a requirements.txt, and any other artifacts that are required for our RAG workflow to work. Opening our main.py, we'll find this is where Wallaroo's custom framework gets implemented. It's where we define how we wish to load our models, along with how we wish to implement our model workflow. Over here, we leverage two classes, a class which inherits from the inference builder class, and another which inherits from the inference class. The class which inherits from the inference builder class loads our embedding model, our llama CPP model, and other artifacts which will be used throughout our RAG workflow. The class which inherits from the inference class is where we define our workflow and leverage our previously loaded artifacts. In it, we'll find the predict function, which defines the core of our workflow. In this example, our RAG workflow is defined here, where we take the customer's prompt and ID, then generate a personalized response using their data stored on an on-prem MongoDB server. And because Wallaroo's custom framework is highly flexible, we can tailor our workflow's complexity as needed. That could range from basic evaluations to more sophisticated prompt engineering or RAG pipelines like the one shown here. The other functions throughout this class are our helper functions, which allow us to successfully implement and run our RAG workflow. Scrolling to the top of our main.py, we'll find that we accept an environment variable and use that to make a connection to our MongoDB server. Moving back to our notebook, having uploaded our model, we can move on to our next step, which is defining our deployment config. This is Wallaroo's approach to help abstract away the complexities, simplifying how we configure our deployment hardware. In our instance, we'll allocate 1 CPU and 2 GB to the engine and 14 CPUs and 18 GB to our RAG model. We're also able to pass environment variables to it, which we can then use in our RAG model, as we saw earlier in our model's implementation. Now that we have our model uploaded and our deployment configuration set up, we'll move to building our pipeline. To build it, we'll pass it a name and we'll add our model to it. Now that we've created our pipeline, I want to step out of our notebook and head to our Operations Center. This is our central way with Wallaroo to manage, observe, and administer our artifacts. If we step into our pipelines, we'll find our created pipeline. Double-clicking on that, we'll find the model associated with our pipeline, along with the pipeline's versions. We can also find our API endpoints that we can use to make our API calls if our pipelines were to be deployed to the Operations Center. For today's demo, we won't be deploying to the Operations Center. Rather, we'll be publishing our pipeline for it to be available at our on-prem Power10 node. Let's head back to our notebook to see how we can do that. Publishing our pipeline can be done with one extra line of code. To it, we'll pass our deployment configuration we defined earlier. By publishing our pipeline, we'll take the artifacts, dependencies, and whatever else is required to make our pipeline work, and we containerize it, creating a standalone process which we then push to our container registry we told Wallaroo about. We're then able to take it from there and deploy it to our on-prem Power10 node, allowing us to stand up a fully functional self-hosted API endpoint that can be used as we would a traditional cloud-hosted LLM endpoint, powering our LLM-driven workflow. We'll find that publishing our pipeline gives us a few outputs. We can see the path to our engine and pipeline artifacts inside our container registry, and if we scroll down a bit, we'll find a Docker command. We can now take that command And because Wallaroo's artifacts are OCI compliant, we have the flexibility to use either Docker or Podman for deployment. In this demo, we'll use Podman as our on-prem Power10 node is configured for it. On our screen, we have two terminals. The terminal on the left is our on-prem Power10 edge node, which also has our on-prem MongoDB server. This is where we'll deploy our RAG pipeline. The terminal on the right, which is on the same network, represents our application layer where we'll make our API call. We'll find that our Podman command is essentially a copy and paste of our command produced when publishing our pipeline. We can also see that we're passing our pipeline an environment variable, which will allow us to connect to our on-prem MongoDB server. We've already ran our Podman command deploying our RAG pipeline. Because it's deployed, we're now able to make our API call. Retrieving our response, we'll find what's returned are the inputs we provided along with our generated text and some metadata accompanying our inference. And with that, we've demonstrated how Wallaroo enables seamless integration of our RAG workflow. We saw how Wallaroo's flexibility allows us to use one of its many supported model to silicon paths to easily package, upload, and deploy our pipeline to an on-prem Power10 edge node. This enabled us to stand up a fully functional self-hosted API endpoint, leveraging our on-prem MongoDB vector database for efficient, low-latency data access, a distributed setup which allowed us to leverage both our application and our MongoDB server co-located on our Power10 node. To visualize this, on the left, we can see that we began with an environment-agnostic pipeline definition. From there, to accommodate our on-prem Power10 environment, we packaged and prepared it for deployment on IBM's Power10. A process Wallaroo simplifies, allowing us to take that same pipeline definition and seamlessly target different kinds of infrastructure. Finally, it's important to highlight that Wallaroo also supports a feedback loop back to our Operations Center. Even though this is an on-prem deployment, we can still send our inference logs back to be observed in our Operations Center. This allows us to take advantage of Wallaroo's built-in monitoring capabilities, including LLM listeners powered by Wallaroo's assays, allowing us to continually observe our pipeline in production.